In the given question, there is a body having mass m, capital M, and another having a small m. Both of the bodies are initially at rest and mentioned on the horizontal table. They are connected by a spring of spring constant k. These two balls are stretched with length L. So when stretching length L, this ball might be stretched toward this word, and this ball toward this word. So while after stretching L length, these balls are released. Then after releasing these two balls, they are connected via a spring, so they will produce a oscillatory motion. So in this question, we have to find find the velocity of oscillatory motion. Velocity of which ball? Velocity of this small ball. So since these balls are initially at rest, so initial moment of these balls is 0, since both of them are at rest. And the final momentum of the ball will be capital M, capital V plus small m, small v. Since these balls are stretched, so velocity while going toward this word, velocity of this ball will be in this direction, and velocity of this ball will be in this direction. So velocity of both of these are in opposite to each other. So we consider velocity of this capital ball as capital V and a small ball as small v. So final momentum of the ball become capital M. This expression become the final momentum of the ball, and by the conservation of momentum, we got capital V as mv, small m, small v upon capital M, and small v as this value. After that, initial energy when body are at rest, they are connected by a spring constant k. So they possess a certain potential energy. Initially at rest, so they possess a potential energy, and then their initial energy became half kl square. And when the body are released, then they perform they are in motion. So after in the motion energy of the body became half kx square, half mv square, and half mv square. Then by the conservation of energy, initial energy must become in final energy. Half kl square equals to half kx square plus half mv square plus half mv square. By solving this by solving in step by step, we got expression as v we got this expression, and this expression. And for the maximum velocity, x must be 0, since when body will have maximum velocity, when body will contract, and when there is the final limit of their contraction or expansion, then the body will have 0 extension, since the body will have maximum velocity at which time? when at place from where body were released. Initially at initial position where body were rely, at that position body will have maximum velocity. So at that place x must be 0. So when we put x equals to 0, then we got this final expression. Thank you.